pointed out, even though I wasn't here, I was not expecting to speak to so many people in such a big venue with such a high quality production. So apologise if you were a bit rushed, but here we go. Right. So I'm Matthew Pickering, and I'm one of the people who contribute most regularly to GHC these days. And whilst I'm contributing to GHC, there's certain elements of friction which I encounter on a regular basis. So I spend a lot of my time trying to make the development process for GHC smoother, working on the infrastructure, CI, developer tools. So this talk is about developing tools which are useful when working on GHC. Okay. So people come work on GHC from different perspectives. You've got your main man, Ryan Scott, on the left here, and he's mostly using normal Haskell interactive development features like GHCI and things like that. Ryan Scott likes to keep things quite simple. But he would also quite like to use GHCI when working on GHC, which was not been possible before. You've got Alan Zimmerman in the middle. He's the author of Haskell IDE Engine, so he would like to use Haskell IDE Engine when working on GHC. And then finally, you've got me. Obviously, I'd like to use Nix in some manner when working on GHC, so I also have a few scripts which make using Nix whilst working on GHC a little bit integrated a bit better. Okay, so Ryan, his first goal in life is he wants a script which he can run, which loads GHC into GHCI. So most Haskell developers will think this is a bit simple, and it is, but people who work with GHC will know that for a long time, the best that you've had is tags files. You can jump to definition, and that's it. So being able to load GHC to GHCI is a massive improvement for us all. So a quick demo of how this script works. I go to GHC source code, I type page in GHCI, and if anyone knows anything about GHC, people expect this to take the whole 30 minutes of my talk. So we'll see. Looking good so far. Okay, so that was quite fast because it was cached. It cached the interface file. So let's remove the cache, as that wasn't really fair. But, it's obviously a better thing about the script that does cache the interface files. But this is from a clean load with no interface files, compiling all 508 modules on the latest branch of GHC, plus 8 modules from when I wrote this script. Another advantage is you now know how many modules GHC has at any moment in time. And you also, if you look carefully, you can see which modules are so on to compile. So it has some additional benefits. Eventually, we're going to get to the 508 module and be happy that we finally have a way to load GHC into GHCI. So once I'm here, I can ask the type of main, and the type of main is IO, and you can ask the type in definition. If you're paying attention, you'll notice this script does not compile the interface files. It only typeface modules. So you can use it to find types, and you can use it for fast feedback, but you can't use it for running code, which is a small limitation, but it's still an improvement on today's code. So that's the Asian GHCI target. Okay, so Ryan's still not satisfied, so it's good to satisfy Ryan.
Question again?
Yes, question Richard.
So, if after you build GHC, you can run GHCI and build stage 2 GHC. And then you try and set that package, GHC.
Yeah.
Then you can import GHC modules to further
So this is using the boot compiler to load.
Right. No, I see how it's different.
Right.
I mean, I see how the process is different. How is the outcome? Why do I want to do this instead of just use it for the food?
Yeah, so you don't have to build stage 2 first. That's the main difference. So when I run that script, nothing is built in the build tree apart from the dependencies, GHC's dependencies.
Oh, so you're loading into stage 0?
Yeah. So you load stage 1 into stage 0, which is why you can't compile anything, which is what I'm going to explain in views like that. Yeah, okay. Yeah, John?
I think you also change something in reload and it'll quickly update, whereas if you set that back in GHC, then you'll have to quit and
Yeah, so Chang's point is that when you change something, then you quickly reload and create a new type without having to compile the whole of the stage 2 package again and relink it. So,
this kind of handle requires an Alexa because they use processors. Or can it?
Yeah, so if you change the parser, so So last question, if you change the path on the left then you have to run a preprocessor in order to regenerate the Haskell files. And yes, that is true, then you do have to restart the target. But it's quite fast to restart. If you restart the target, then it will call the preprocessor again. But it's like the normal limitation of GHCI, where GHCI does not rerun preprocessor for you.
But GHCI cannot handle this, right?
Well, with GHCID, which I'll talk about now, you pass the extra restart flag, and then if you pass restart to the parser.y or the Lexa file, then it will restart the whole process when those files change. Okay. So the second basic piece of tooling is GHCID. So all GHCID needs is a way to load GHCI. So thankfully we've already implemented that. So if I type GHCID in the root of the GHC directory, because I've already compiled GHC once, all the interface files are there, so it's quite quick to load, and you get a working GHCID session. So now if I go to one of the modules, and it doesn't really matter which one. Okay, if I introduce a typo in one of these modules, okay, it recompiles, and it says I have could not find the module. Okay, that's definitely a typo. What about if I change, so list CPS 3 variables, I delete the type signature, then I should get a warning which tells me that I now have top level binding no type signature, and it tells me the type. So I can copy this type from this terminal, paste it into my session, and be on my way developing GHC just like I develop any other Haskell project. That's the goal here, to make it developing GHC like the Haskell project. Okay, so the GHCID config is quite simple. All it does is first there's the command to call, which is the Hadrian target for GHCI, and then it says, okay, if I change any file and compile, GHCI includes, just call the reload option in GHCI. But if I change any file in the Hadrian subdirectory, then you need to restart the whole session because you changed the build system in some way. So as I pointed out before, yes, I also need to add a restart directive here, which restarts if you change any file which is generated. But I haven't got up there yet. Okay, so now we've got the two basics, nice and simple. Now we want to run main though. And running main is quite problematic because of how GHC's main works. The current situation is that we have loaded stage 1 into stage 0. So stage 0 is GHC 6.5, stage 1 is this development version of GHC. And now in order to run main, we also need the libraries, which GHC 8.9.0, 2019, 06, 11 depend on, built with that version of GHC, which we don't currently have. So that running main in this setup doesn't work. Okay? So trying this main idea, and in the original GHCI script, this is how it works. First, what you do is you have to build a stage 2. And then you load GHC into the stage 2 compiler, which has the same versions of the libraries as the version of GHC you loaded into GHCI, and then you can run main, in theory. And I have got this to work one time, but currently the build, for some reason, doesn't work, and I didn't have enough time to debug why. So it currently doesn't work, but in theory it does work, and I have made it work once. So when you can run main, you can run any function in GHC's less than like a normal experience, and you can compile a module using GHC and so on. So that works out quite nicely. Okay. Right, so once you can run main, you can also run the GHCI debugger. I don't have an example doing this because it's broken at the moment. And also there's a question mark, because I don't actually know if anyone uses the GHCI debugger or is interested in using the GHCI debugger on GHC. But it does work, because I have done it. But, no one yet has laid a claim to the question mark, so if you want to be on my slides next time, then tell me about your favourite GHCI debugging story. Right. Once you have GHCI targets, you can also, well, I thought once you have the GHCI target, then it also would be straightforward to start using Haskell ID engine on GHC. It turns out this required quite a significant amount of refactoring in Haskell ID engine, about 2,000 lines or so. But once that small amount of refactoring has been done, you can also use Haskell ID engine on GHC in VS Code. So let's try that. So how the new branch of Haskell ID engine works is it calls, all it needs is the arguments that you pass to the GHCI target. So there's a new target for Hadrian, which produces these, it produces these arguments, which then get passed to Haskell ID engine, which creates a session, and it works just like any other Haskell ID engine session. So if we go to GHC, and I'm now going to call our RT module, okay, and then my branch produces quite a lot of output, but that's normal for my branches, I'd say. So now we're loading the call RT module, and if we wait a little while, just a short while, eventually we'll be able to hover over the type, scope of definition, peak definition, and so on, all the normal things that people who use Haskell ID engine on a basis are used to doing. Right, so now we've successfully loaded. I can hover over here, I can say, okay, that's an int. Minimum, what's the type of minimum? Okay, minimum is RT to RT, that's good. Split strict. Okay, what's the definition of that? Okay, that's defined there, that's good. What about go to definition? Does that work? No. Okay. Well, it was good while it lasted. Right. So it's not perfect at the moment, and I wouldn't recommend anyone tries using this, but there's a proof of concept that it's possible. So they're the like interactive development aspects of that I've been working on. So you have Haskell ID engine, GHCI debugger, running main, GHCID, and GHCI. So is there any questions about those aspects before we'll go on to the boring bits about Nix? Okay, right, so the second aspect is to please myself mainly, and like how can I maximize my use of Nix while working on GHC? So first, very useful thing that's been implemented is Alb's repo is called GHC.Nix. So GHC.Nix is all about setting up the environment for building GHC. So I know quite a lot of developers use Nix, and they use this to set up all the build dependencies they need to build in GHC. So I think glad you use it.
Yes.
Glad you use it on a Mac.
Yes.
Even braver. Yes, glad you use it as well. So I'm just about, yeah, so we've got multiple people using it. And it makes it really simple just to drop into the shell, and then you've got everything you need to build GHC without worrying about any of the dependencies. Okay, so that's quite basic use of Nix. More recently, I've been trying to take advantage of the move to GitLab, and now on GitLab, for every commit and every merge request and every branch push, CI runs on these branches. Okay, after you've built many different builds of GHC, all the build results for these builds get uploaded to a content provider, and then you can download the build results using your own computer or in order to test something about the build. Okay, but downloading these bin disks is not that easy if you're a normal user, because you have to download them and then you've got to install them by mutating your system state and then uninstall them and all this stuff. So I made this script which simplifies the process, and what it does is it downloads the bin disk and makes a Nix shell which gives you access to that bin disk, and you can use it just like a normal version of GHC in that context. So there's 3 modes of operation. The first one, when you call the script without any arguments, just downloads one of the recent clips from master. So if you want to show one of your friends like the coolest new feature of GHC which just landed, you can run this script and wait about 3 minutes, and then it will be available for you to use as normal to show your friend the feature. If you're a developer and you want to test a merge request, you can specify the merge request number, and then it'll download the bin disk for that merge request. If you want to test out some changes, look at the documentation that someone has modified, check is it okay? And finally, if you have a friend who has not submitted a merge request, written a GHC proposal, or upstream their patch to master, but has a secret branch that no one knows about, then you can pass it the direct linked to the tarball, and it will download it and package it for you. So this is the only way that I knew possible to try Tremors and saturate type on this branch, which does exist, but it's very well hidden.
You can build it from source.
You can build it from source.
Yeah.
That was the comment. Well, thanks. try it. Okay. So the three ways of operational scripts, and finally, on a similar theme, if anyone's used Nix, they know full well that the Nix developers delete all attributes of GHC quite quickly. So I made a repo which just has all the old versions of GHC packaged in the same way, back to 8.0. And this also, you can use the GitLab artifacts in order to, in your own Nix expressions, in order to depend on a branch or anything you want. So I've been using this to set up an environment which has the 8.8 release in, so I can use it working on some new features in 8.8, which the library depends on. Okay, so that's it. Has anyone got any questions about all these amazing features?
Then we go to declaration.
So?
Then we go to declaration.
Go to declaration. So go to declaration does work. Yeah, I mean, this bug is one that Luke and I were trying to fix like half an hour ago. But it didn't happen when we were trying it like before, but now I did. Like, what's going on with that? So I don't know, maybe 10 minutes, maybe never will. Who knows? Works in theory. Yeah.